I think we are good. It's time to go. So, welcome everyone. Thank you for attending to this session. My name is Michael Barbero. I work for Obio. Obio is a company which is editing a lot of tools around modeling, and today I want to share with you some knowledge that we had acquired by using EMF. So, first, I have a question for you. Obviously, now it doesn't work. Yeah. Who knows EMF there? Okay, so almost everyone. That's good. So for people who don't know, EMF can be considered as a framework to generate super Java beans and super Java beans on steroids. But steroids are not useful if you don't work out. So today I propose you to work out a bit. And we will start by, I will not use this anymore. We will start by seeing how to connect a viewer to an EMF model and to display it and to let you edit such a model. Then we will see how we can change the label without modifying the generated code from EMF. And then we will see how we can change the contents of a tree viewer. You can change the way the model is displayed. So first of all, let's see how to connect the viewer with your EMF model. So I expect from you that you know a little bit about JFace, especially the tree viewer of JFace. So you may know that you have to provide a content provider and a label provider to a JFace tree viewer to display some element within it. And I'm also expecting from you that you are quite, you know a little bit about the MVC pattern, the model view controller. And that the model view controller pattern is mainly based on the observer pattern, which means that you have to listen for changes and to react to some other changes. EMF actually provides you freely a very powerful observer pattern, but it can be a little bit hidden when you start with EMF because the usual concept of the observer pattern are not called the same way in EMF, so you get the concept of notifier and adapter. And if you know the observer pattern, the notifier is actually the observable element, and the adapter is a listener of this observable. So the adapter adapts the notifier, registers himself to the notifier, and then the notifier will send some events to the adapter. Those events are implemented by the means of notification. It is the interface notification from EMF. So whenever you see a notification within the framework that go from an object to another one, it is actually an observable that is triggering its observers. So let's come back to the JFace tree viewer. How does it work? So we define there the tree viewer, and we have to set the content provider and the label provider on this viewer. EMF actually provides some very useful implementation of those content provider and label provider, which are called AdapterFactoryContentLabelProvider and AdapterFactoryContentProvider and AdapterFactoryLabelProvider. Those classes do not need to be customized. Most of the time when you start with EMF, you are customizing those classes, but actually they don't have to. Because what they are doing is delegating to some more powerful framework. So initially you set the content and label provider to the tree viewer, and those providers are calling what is generated from EMF, and this class is generated from EMF. It is called ItemProviderAdapterFactory. So when you ask, for instance, when the tree viewer asks for the label of an element that it has to display, it will ask to its label provider, which will delegate to the ItemProviderAdapterFactory, which itself will actually create an item provider, which implements the logic of creating the label for the element that you want to display. This is a bit complicated, but you will see the power through this presentation. The power comes from the fact that every link is actually bidirectional. So the tree viewer knows about the content and label provider, but those provider also knows about the tree viewer. The adapter factory knows about the label provider, and the item provider knows about the adapter factory that created it, and the object knows those item provider. And this is why the dispose method is very important on the item provider, because if you don't dispose properly all this graph of object, you will have some memory leaks, because your object knows all of its listener, which knows all of its adapter factory, which knows about the label provider, and then knows the tree viewer. But this framework allows you to do very smart thing. Especially, it lets you refresh and update the viewer very smartly. Why? Because when your object is modified, you change the name of a book. It notified the item provider which is listening for the e-object. This item provider gets the notification from the object. And through this notification, it knows what has changed. And as it knows what has changed, it is able to resend an event that will be very, very specialized to update only a little part of the tree viewer and not the whole tree viewer. So here we change the object, the name of the object. It forwards the event to the item provider. It filters it out to send it to the adapter factory, which sends it to the label provider, and then to the tree viewer. And then your UI is refreshed very smartly. There are several, actually two kinds of provider type. If you ever go through the gen model of EMF, there are some options on each E-class on the gen model to select the provider type. So the default type is singleton 1, which means that the generated adapter factory will only create a single instance of item provider for every kind of object that it adapts. It means that this listener will listen to a bunch of objects. The second kind is a stateful one. And when you select the stateful provider type, then the item provider will create a new listener for every object that it has to adapt. So this is useful if those item providers are actually stateful, that they had to know which element they adapt to be able to compute the label. Most of the time, all of the book have the same label. The label is computed the same way, but sometimes you have to have some context, you have to keep some state, and then you have to change the provider type. But even more, this framework lets you do even smarter things. For instance, in this application, I want to display some books from a model of a library, and I want to display an e-core model along with it. And what lets me do that is a very interesting class, which you may have used before. It's a composed adapter factory. It lets you create a composed adapter factory that will delegate to the proper one when the label provider and the content provider are asking for a label or some children. This is what lets you create such kind of UI. And now I will show you how it works a little bit more. So here, for the sake of the example, I created an application the old way, meaning I created the tree viewer and implemented the content provider interface and the label provider interface by hand. And then you can see that I have a lot of if-else-if instance of to create to be able to dispatch the logic of my application. Now, with EMF, I just have to set the very useful implementation of content provider and label provider. I created a composed adapter factory in which I set some adapter factories that are able to display any kind of object from EMF, and also an adapter factory that is able to display resources. So it will display the URI of the resources. So what does it do? So here I got my very simple application, and every object are displayed exactly the same way because they are only calling the reflective item provider, which is displaying, for instance, the name of the class and then some the first string attribute that it finds in the model. So this is not quite good now. We want to improve this application, and I want to delegate to the proper item provider. So now I add the item provider generated from my model, and I also add the item provider of eCore, so that I will be able to display eCore model also in my tree viewer. If I launch it again, now you can see that every object is displayed the proper way by delegating to the item provider each time. So all the code of those examples are available. I will also upload the slide just after the presentation, so you will be able to get this URL after that. As you can see in my Git history, there are some tags for you to get every steps of this presentation. So we have seen how to display some EMF model within tree viewer. Now we want to customize it. So how do we change the label of any object? So the obvious way, the easy way, is to change the generated code, is to change the getText method of the item provider. But this is not quite good because by using that, if you change the generated code, you lose most of the benefit of having code generator, meaning that after a certain given amount of time, you will not be able to find out which part of the code is generated, which part of the code is manual. A common pattern to avoid this situation is to use the generation gap pattern, meaning that you want to treat your generated code exactly as your bytecode. And most of the time, you can implement this by generating your code in a given source folder and to create, to put your manual code into another source folder. And then by playing with inheritance, you can customize the generated code in the manual source folder. But yet, it is not entirely good because all of the item provider are implemented in the generated code. And in this situation, where this is an excerpt from the library eCore model, so I got an item of my library, and I have 4 subtypes of item in my library. So I got some books, periodical, and so on. What if I want to customize the label of any kind of item in my library? If you want to do that, you have to subtype to create manual code for each subtypes, because each subtype has the getText. So even if I override this one, those generated classes will not benefit from it. But EMF provides a very useful but misknown class to do that. This class is called decorator AdapterFactory. We will decorate the generated ItemProviderAdapterFactory that will create decorator of item providers, and this way I will be able to customize even an abstract item provider instead of subclassing every subtypes. Let's see how to do that. So first change, I added to the composed adapter factory a decorator adapter factory for my library meta model. Let's have a look at the class. So it's very simple. It extends some class from the EMF framework. And then it says that for each item provider decorator that I want to create, I will, if the target, so if the element that I want to adapt, I want to listen to is an item, I will create an item provider decorator, sorry for the name, but it is the name of the class. And otherwise, I will always forward to the generated one. So the forwarding implementation is not interesting, but the decorating one for item is much more interesting. So you can see that I only extend another class from the EMF framework, and I only override the getText, so the getLabel method from the ItemProvider. And I want to add as a suffix of the original label the publication date. And I want to do it for book, for videotape, and so on. So this way, I am able to customize the label for every subtypes and not only concrete types. So let's launch that. May have to kill this one. And as you can see, I got a videotape there with the publication date, and also all the book have the publication date. So very useful, and it can save you days of debugging, and it saves you from modifying the generated code of EMF. Again, it's available in the same GitHub repository and the new tag name. So now we change the label, but we want to change the way the elements are displayed. By default, EMF generates item provider regarding the tree structure that you are defining in your core model. It means that if you define a library that contains item, then it will generate item provider that will display a library, and as its child, it will display the item. But what if I want to change the way it is displayed? So again, the obvious way is to modify the getChildren code, but we have already seen that it's not the best way to do that. And what we want to achieve is actually this one. So here I want to display the writer of a book as a children of the book, even if the relationship, the reference between the book and the writer is not a containment one. So here I want to display the same element at several places, several locations in my tree. And I want to do it efficiently. Again, EMF comes with a very useful framework for that. This is a very tiny eCore model that is defined in the Edit plugin, which is a tree model. So you got an E-class tree node that can contain other tree node, and every tree node reference an E-object. So you can create a complete tree of elements that wrap E-objects, other E-objects from your actual model, here or library model. And even better, this tree model is coming with an already done decorator ItemProviderAdapterFactory and decorator ItemProvider that will forward all the events and all the messages properly to the E-object. Meaning that here I wrapped my E-object into a tree node. When my E-object is modified, it will notify its ItemProvider. But this ItemProvider has been listened by the tree node ItemProvider, which will forward to its ItemProviderAdapterFactory and then notify properly the viewer. So then I am able to change completely the way the elements are created by creating a tree model of some elements. And if I register the proper adapter factory, it will even send the events properly. But there is a caveat, some big troubles. You can face some big troubles with this implementation. I was faced with that, and I struggle a lot to debug it. You can reach a lot of modification. You can get a lot of modification in your tree viewer with that pattern. So let's see why. So you got your bunch of e-object, so your books you want to adapt, and you wrapped it into some tree nodes. Obviously, those tree nodes are adapted by tree node ItemProvider that are listening to the change of the tree node, but they rarely change. The only change that can happen is they are moved into the tree or the wrapped element has changed. It's not advised to do that. And you got the ItemProvider of the elements that are listening to this e-object. So what happens when this object changed? It notifies its ItemProvider because this one has registered a listener on the element. But then, as each tree node ItemProvider are listening to the same e-object ItemProvider, I will demultiply the number of events that will be sent to the UI. Because if I change there, here it will be notified. It will notify all of its listeners, and all of its listeners are these tree nodes, and this tree node ItemProvider, sorry, will notify the UI once each. So we don't want that. And what you want to do is to use some stateful ItemProvider, because now each time the object is adapted, you get a new ItemProvider, and then the tree node ItemProvider is listening to only one, and then we'll get only one notification, and we'll be able to send only one notification to the tree viewer. So let's see that in details. So first of all, I want to show you how I created my model. So it is only programmatic creation of an EMF model. And I got also this utility method that creates a tree node model from from a library. So as you can see, I'm browsing all the items in the library. And when I'm on a book, I create another node that I add as a children of the parent and set the data to the author. And despite this getAuthor method is not a containment reference, as I add the tree node as a children, it will be displayed properly as a children in the viewer. So now I will just change the input should not be that. Sorry about that. Let's see if it works. Yeah. So now I am giving as an input of the tree viewer not my original model, but my tree node, my model of tree, my tree node model. And then the last thing I have to do is to add the ItemProviderAdapterFactory of the tree model. This way, I'm able to display the tree model. Here, it's not some books and some authors that are displayed. It is some tree node that wrap the other object, but the events are properly forwarded, and they are forwarded only once because I changed one thing in my gen model. So here is a gen model of my library. And if I look at the property of every e-class, you can see that the provider type is set to stateful. So there, with that, I will not have the demultiplication of events in the UI. So you will have better performances. Obviously, it will consume some memory. You are doubling the size of objects that are to be created, but you are able to customize the UI very efficiently and very easily. Again, same GitHub repository. So, as a recap of this presentation, we've seen how we are connecting the viewer and an EMF model. The very basics, the usage of AdapterFactory, label and content provider, the usage of a composed adapter factory to be able to display multiple kinds of elements from multiple kinds of model. We've seen how we can change the label of elements without touching the generated code, and we've seen the way how to change the way elements are displayed, or to change the contents of the model without touching the generated code of ItemProvider. I think I got a few minutes for questions, if any. Yeah, just a little remark. This book is quite old, but it contains everything I presented to you, so it's already in there. Just have to find the good chapter. It's not often it's not presented with a use case. It's only presented some part of the framework. But if you look for 3-node model and the ItemProvider, you will find everything you need in this book. So now we got some time for questions. Nobody? Okay, so do not hesitate if some pops up later to come by to see me, and thank you very much for your attention.